One of the most fascinating things about existing is that we have absolutely no idea what is going on. We wake up on this floating rock, we pay taxes, we eat snacks, and we look up at the sky and wonder what the point of it all is. And just like we are all secretly, or not so secretly, obsessed with knowing what happens after we die, scientists have been obsessed with asking how the universe itself will kick the bucket. Today we are going to dive deep into the 10 leading theories on how the party ends. The Big Crunch. Let's start with the classic, the sequel to the original hit. You know, the Big Bang, right? About 13.8 billion years ago, everything we know, every star, every planet, every embarrassing text message you've ever sent was squished into a singularity. That is a fancy word for a point that is infinitely dense and incredibly hot. It was the ultimate pressure cooker. Then, for reasons we still argue about, it exploded, or expanded, rather. It blew outward at a speed that is hard to comprehend, creating the universe we see today. The Big Crunch is basically that movie played in reverse. Right now, the universe is expanding. Think of it like a ball you threw into the air. It is going up and up. But in this theory, gravity is the ground. The idea is that all the mass in the universe, the galaxies, the dark matter, the black holes, has gravity. And eventually, that gravity acts like a leash. It pulls back. According to the Big Crunch theory, the expansion of the universe will eventually slow down. It's like that ball reaching the top of its arc. It hangs there for a split second, and then it starts to fall back down. The universe stops growing and starts shrinking. Now, this sounds terrifying, and it is. Imagine the night sky. Over billions of years, instead of galaxies moving away from us, they start rushing toward us. The universe gets smaller, it gets hotter, it gets more crowded. All that material, planets, stars, gas clouds, gets dragged back to the center. It is the ultimate cosmic traffic jam. Eventually, everything smashes together. The temperature rises to unimaginable levels. All matter is crushed back into that same infinitely dense singularity we started with. Everything is wiped out. No record of us, no record of the stars, just a hot, tiny dot waiting for, well, maybe another Big Bang. The only catch with this theory: we have recently discovered that the universe isn't just expanding, it is accelerating. It's like you threw the ball up, and instead of slowing down, it strapped on a rocket and flew away faster. So, right now, the Big Crunch is looking a little less likely. But you never know. Gravity plays the long game. The inevitable heat death of the universe. If the Big Crunch is fire and crushing pressure, this next one is the exact opposite. It is called the heat death, or sometimes the Big Freeze. It sounds like a bad wrestling move, but it is actually the most lonely way to go. Think of the Big Crunch as gravity winning the tug-for. Heat death is what happens when gravity loses badly. In this scenario, the expansion of the universe just keeps going. It doesn't slow down. It doesn't stop. The galaxies drift apart like friends who promised to keep in touch after high school but never did. The space between everything gets wider and wider. To understand this, you have to understand a little bit about thermodynamics. I know, I promised no jargon, so let's use an analogy. Imagine you have a hot cup of coffee in a cold room. Eventually, the heat from the coffee spreads out into the room until the coffee is cold and the room is just a tiny bit warmer. Everything reaches the same temperature. That is called equilibrium. The universe is basically a giant cup of coffee. Right now, we have hot spot stars and cold spot space. But given enough time, the universe will spread that energy out evenly. Stars run on fuel. They burn hydrogen. Eventually, every star in the sky will run out of gas. They will flicker and die. And here's the sad part. The universe will be too spread out and too exhausted to make new stars. The lights go out one by one. The universe becomes a vast, dark, cold mist. Matter will still be there, but it will be in particle form, just floating around randomly. Nothing bounces off anything. Nothing happens. Time essentially loses its meaning, because if nothing changes, does time even pass? We are left with a cold, dark, boring void forever. It is the ultimate ending where the universe just kind of gives up. Heat, death via black holes. Now, let's spice up that heat death scenario a little bit. This version involves the monsters of the cosmos, black holes. We know that black holes are everywhere. There is a supermassive one in the center of almost every galaxy, including our own Milky Way. These things are the vacuum cleaners of space. Their gravity is so strong that not even light can escape them. If you get too close, you get spaghettified, which is a real scientific term that means exactly what you think it means. In this theory, as the universe ages, matter tends to clump around these black holes. Over eons, black holes will do what they do best: eat. They will consume stars, planets, gas clouds, and even entire galaxies. They will cannibalize each other, merging to become even larger, scarier black holes. So, picture a universe that is mostly dark, with these massive gravity wells lurking in the abyss. Occasionally, you might see a flash of light, like a cosmic lightning bolt, as some stray piece of matter gets too close to a black hole and screams out energy before falling in. But mostly, it is dark. Eventually, the black holes eat everything. There is no normal matter left, just black holes in the dark. But even they aren't immortal. A brilliant physicist named Stephen Hawking figured out that black holes actually leak. They emit something called Hawking radiation. It is very slow, but over unimaginable periods of time, black holes lose mass. They evaporate. So, after the last black hole has eaten the last star, the black holes themselves will slowly fade away. They will shrink and vanish, leaving behind nothing but a thin soup of subatomic particles. We end up in the same place as the regular heat death, a uniform, empty, dark nothingness. But we took a much more violent and hungry road to get there. The end of time. This one is going to hurt your brain a little bit, so stick with me. We usually think of time as the one thing that is constant. Whether the universe is full of stars or full of nothing, time should keep ticking, right? Tick-tock forever. But some scientists think that time itself might be the thing that breaks. Here is the logic. Assume we live in a universe that lasts forever. If you have an infinite amount of time, then anything that has a probability of happening, no matter how small, will eventually happen. In fact, it will happen 100% of the time. It will happen an infinite number of times. This creates some weird paradoxes. For example, if you were immortal and lived forever, the chances of you getting stuck in a hole or trapped under a rock eventually reach 100%. You would spend eternity trapped. Physics relies on calculating probabilities to predict things. If everything eventually has a 100% chance of happening because time is infinite, then the math breaks. You can't predict anything anymore. To fix this, some theorists suggest that time itself must stop. Imagine the universe billions of years from now. You are somehow still alive, don't ask me how. Maybe you ate a lot of kale. Suddenly, everything just freezes, like pausing a movie. But you can't unpause it. It wouldn't be forever in the way we think of it, because forever implies time is passing. It would just be that one single instant locked in place. It is a snapshot. You wouldn't die. You wouldn't grow old. You wouldn't even know it happened because your brain neurons would freeze mid-thought. The universe becomes a static image, preserved for eternity. It is a kind of accidental immortality, but arguably the most boring kind possible. Big bounce. Okay, let's get a little more optimistic, or at least less permanently destructive. Remember the big crunch? The one where gravity pulls everything back into a tiny dot? Well, the big bounce is what happens next. In the big crunch theory, everything gets destroyed. But in the big bounce theory, the universe recycles itself. Imagine the universe is on a giant bungee cord. It expands out. The cord pulls tight. It snaps back, crunches down, and then, bowing, it bounces back out again. The idea is that the rapid compression of the universe back into a singularity generates enough energy to trigger a brand new Big Bang. The slate is wiped clean, and a new universe is born from the ashes of the old one. This is called an oscillating universe. It implies that our Big Bang wasn't the first one. We might be living in universe number 1, or universe number 50 million. There is no way to tell. It's a nice thought, right? It means that even if everything we know ends, the concept of existence doesn't. It just reboots. Maybe in the next version of the universe, pizza is a health food and we all have wings. Or maybe in the next one, we are all sentient clouds of gas arguing about politics. Who knows? But the idea that the universe breathes in and breathes out over trillions of years is strangely comforting compared to the eternal frozen void. The Big Rip, all right. Comfort time is over. Let's talk about the most violent, aggressive, and terrifying theory on the list. The Big Rip. This theory is all about dark energy. We don't really know what dark energy is, but we know it acts like a repulsive force. It pushes things apart. It is the reason the universe is accelerating in its expansion. In the Big Rip scenario, this dark energy gets stronger and stronger over time. It becomes a phantom energy that grows more powerful as the universe gets bigger. Eventually, it gets so strong that it overcomes gravity. Then it overcomes the electromagnetic forces that hold atoms together. Here is the timeline of horror. First, the galaxies get torn apart. The stars drift away from each other much faster than normal. Then the solar systems get ripped apart. Planets are stripped away from their stars. Then the planets themselves explode because gravity isn't strong enough to hold the rock together against the expansion. But it doesn't stop there. In the final moments, the expansion becomes so fast and so powerful that it rips atoms apart. Your molecules dissolve. The very fabric of space-time is shredded. The scariest part about the Big Rip is the timing. While heat-death takes trillions upon trillions of years, the Big Rip could theoretically happen much sooner. Some estimates say 16 billion years. I know, that sounds like a long time, but in cosmic terms, that is next Tuesday. The sun will still be around. Life might still exist. And then, suddenly, the sky rips open and everything disintegrates. It is not a gentle good night. It is a cosmic shredder. Speaking of preparing for the future, have you ever thought about how you are going to spend the remaining few billion years before the big rip? You probably want to look cool doing it. That is why you should hit that subscribe button. I can't promise my videos will stop a vacuum decay bubble from eating the galaxy, but I can promise they will keep you entertained while we wait for it. Okay, back to the destruction. Vacuum metastability. This theory sounds like something from a sci-fi movie, but the physics behind it are alarmingly real. It is often called vacuum decay. The basic idea is that the universe exists in a vacuum state. We assume this state is the most stable possible state, like a ball sitting at the bottom of a valley. It can't roll anywhere. It is safe, but quantum physics suggests that maybe we aren't at the bottom of the valley. Maybe we are sitting in a little dip on the side of a mountain. We are metastable. We look stable, but we aren't truly stable. If this is true, all it would take is a little push. A quantum tunneling event could occur anywhere in the universe. If this happens, a bubble of true vacuum would form. This bubble has different laws of physics than our universe. It has a lower energy state, because nature loves low energy states. This bubble would expand, and it would expand at the speed of light. Because it moves at the speed of light, you would never see it coming. 1 second you are eating a taco, and the next second you are simply deleting. The wall of this bubble would incinerate everything it touches. Inside the bubble, the laws of physics would be totally different. Atoms might not hold together. Chemistry wouldn't work. Life as we know it would be impossible. The bubble would grow and grow until it consumed the entire universe, replacing our reality with a new, weird, lower energy reality. Scientists think the universe might actually have to be on this razor's edge of instability for life to exist at all. So, the very thing that allows us to be here is the same thing that could instantly wipe us out without warning. Sleep tight. The time barrier this one gets into the weird math of the multiverse. If you try to calculate probabilities in an infinite multiverse, you run into that problem we talked about earlier. Everything happens 100% of the time. It makes the math useless. To fix this, scientists sometimes take a sample of the universe to do their calculations. They draw a circle around a section of space-time and say, we are just going to look at this part. This works for the math, but it creates a weird implication. If the math only works when you cut off a section of the universe, does that mean there is a real, physical cutoff? Some theories suggest that for the laws of physics to make sense, there has to be a hard boundary. A time barrier, according to some calculations related to this theory. That barrier isn't infinite years away. It could be as close as 3.7 billion years from now. Imagine driving your car down a highway that you think goes on forever, and suddenly you hit a brick wall that simply says the end. Physics says we might hit that wall. We literally run out of universe. We run out of probability. The simulation ends. Now, to be fair, this is likely just a problem with our current understanding of physics. It probably means our math is wrong, not that the universe has a literal concrete wall at the end of time. But the fact that the numbers point to a sudden stop is definitely enough to give you an existential crisis. It won't end because we live in a multiverse. Here is a twist. Maybe our universe ends but existence doesn't. This is the multiverse theory. The idea is that our universe is just one bubble in a giant cosmic bubble bath. There are infinite universes out there. Some are being born right now in their own big bangs. Some are dying in big crunches. Some are freezing in heat deaths. In this scenario, it doesn't matter what happens to us. If our universe rips itself apart, who cares? There are trillions of others. Maybe in another universe, you made different choices. Maybe in another universe, humans evolved from corn. The possibilities are endless. According to Dr. Michio Kaku and other theoretical physicists, universes might sprout from other universes. Black holes might be the seeds for new big bangs on the other side. This means that while our specific address in the cosmos might get demolished, the neighborhood is expanding forever. The total number of universes is always increasing. So, in a way, nothing ever truly ends. The party just moves to a different room. It takes the pressure off a little bit, doesn't it? We are just a tiny, temporary speck in an infinite, boiling ocean of realities. The eternal universe, finally. Let's look at the theory that says, chill out, nobody is dying. The eternal universe. For a long time, humans assumed the universe was eternal. It always was, and it always will be. Then the Big Bang Theory came along and said, no, there was a start date. Put new theories are bringing the eternal idea back with a twist. It involves brains. No, not the things in your head. Brains are short for membranes. In string theory and higher dimensional physics, our entire universe might be a three-dimensional sheet floating in a higher dimensional space. The theory goes that there is another sheet, another brain, floating right next to us. Every few trillion years, these two sheets drift together and collide. When they smack into each other, it releases a massive amount of energy to us. Inside the sheet, it looks like a big bang. The universe heats up, expands, and resets. Then the sheets drift apart. The universe cools down, and eventually they crash again. This is a cyclical model. It means time didn't start at the Big Bang. Time has been going on forever. We are just in the current cycle of expansion. We go through a cycle, we get wiped out by a collision, and we start again, forever. We might actually be able to prove this. Satellites, like the Planck satellite, scan the cosmic background radiation, the leftover heat from the Big Bang. If we find specific patterns in that static, it could prove that our universe bumped into another one. So, in this version, the universe is like a phoenix. It burns up and is reborn from the ashes, over and over again. It is poetic. It is beautiful. And it means that in 1 trillion years, when the brains collide again, the slate gets wiped clean for the next adventure. So, there you have it. 10 ways the story ends. We might get crushed, frozen, ripped apart, eaten by black holes, or deleted by a bubble of quantum doom. Or we might just bounce back and do it all over again. So go eat a cookie, call your mum, pet a dog, enjoy the universe while it lasts. Because even if it takes billions of years, the rental contract on existence eventually expires. Thanks for watching, and I'll see you in the next video, assuming the vacuum bubble doesn't get us first.